Hello students, so welcome back to another class of vectors, vector algebra. I have written vectors, it should be vector algebra, right? Algebra, and this is my third class on this. So initially we'll start with solving a problem so that your memory gets used to vectors, and then we'll proceed with scalar product, dot product. We'll study dot product today. We'll solve a couple of problems on dot product, and that is all. So let's see this problem. The first problem is find the unit vector in direction of sum of this vector and this vector. So there are two vectors a and b. It says find the unit vector in direction of sum of these two. So first you need to find out sum of two vectors. You know, you have to 2i plus 2j minus 5k plus 2i plus j plus 3k. So very easily 2i and 2i becomes 4i, and 2j plus j becomes 3j, and this becomes minus 2k cap. So this is a plus b. Find the unit vector. You know, let this be c vector. Sum of two vectors is another vector. So you know c vector is equal to c vector by mod of c vector. So mod of c vector you have to find out. Mod of c vector is equal to 4 square plus 3 square, and there are certain things I would say just remember. Don't use your brains too much. This is how much? 16, 9, 25 for 29. So this becomes 4 by 29 root 29 I k cap plus 3 by root 29 j cap minus 2 by root 29 k cap. So this was just to bring you in the attitude of vectors, bring your attention towards vectors, nothing else. There is another thing. No, we'll start with scalar product today. That's the topic of discussion. Scalar product. What is scalar product? You must have heard of it, read of it, many things. So product of two vectors. So first of all, product of two vectors, there are two types of product. Product of two vectors, we saw sum of two vectors, difference of two vectors minus when two forces are acting towards each other. The net product is net force is, if when two forces are, say this is, there are two vectors, so this is this minus this, this will be, this become light, this will be, this much will be cut, and you will be left with this much vector. Difference of two vectors. Summation of two vectors, will be simply a big line. This is this, and this is this. So but in vector language you have to add the I components, right? X plus y, I k cap, y plus whatever, x1 plus y1, x1 plus x2, x2, y1 plus y2, which we did just now. Sum and difference you should z1 plus z2 k cap. So now when we talk about product of two vectors, there are two products, two types. Scalar product, which is very simple, or dot product, and there is another thing which is called vector product or cross product. So today we are going to study only scalar product. Vector product will study some other day. So What is scalar product? Scalar product is simply if two vectors are there, say A and B, their dot product is denoted by a dot in between, that is equals to, can somebody recall? It is, first of all, it is just a number. Scalar product is just a number. Scalar product is just a number. There is no sign associated with it. So it's simply modulus of A, which is a number, into modulus of B cos theta. What is theta? Theta is the, let me write the whole sentence, angle between A and B. So it is angle between A and B, that is, and let's solve a couple of problems, or shall we? Yeah, let's solve. And there are certain things which you need to know. If cos theta A dot B equals to 0, if A and B are non-zero, A, B are non-zero vectors, is 0 only if cos theta is 0, because this is not 0, this is not 0. So how can the product be 0? If cos theta is 0, cos theta is 0 means, think simple, theta is pi by 2, 90 degree. So if A and B is 0, if and only if theta equals to pi by 2 or A perpendicular to B. There is no other condition other than A perpendicular to B that the dot product will be 0. So this is one thing you learnt, right? Next we talk about unit vectors. I dot I. How much is I dot I? 1 into 1, right? Modulus of I is 1, right? I into I is 1 into 1. Cos, what is the angle between I and I? 0. So that is 1. Similarly, J into J equals to 1. K dot K equals to 1. Dot product, I sorry, I said into, dot product, K dot K 0, J dot J, sorry 1, J dot J 1, I dot I 1. But if I say I dot J, that is equals to 0, because I perpendicular to J. Similarly, J K equals to 0 and K I is also equals to 0. Understood? Now there are certain things we'll solve a couple of problems. Before that, shall I move to distributive? Distributive, just remember this, A dot B plus C, the dot product of a vector and the sum of two vectors is nothing but A dot B plus A dot C. Just remember this, it is as simple as that. And if you multiply lambda with the dot product of A and B, that is equal to, you can very well bring lambda here. You can also bring lambda A here, dot B. So just remember this. And lambda is a scalar. This is a scalar. Scalar means a number, 2, 3, 4, 5, 6. So if I say 2 into 2i plus 4j plus 5k is how much? you'll simply say 4i, simply multiply 8j plus 10k. This is one thing. Next, let us solve a couple of problems, right? That is what I told initially. We'll solve a couple of problems. So I'm not going into the details. Find angle theta between vectors 1 and 2. Find theta, find angle between A, that is how much, I plus j minus k, and B equals to I minus j plus k. So you very well know that A dot B is equal to A B cos theta. So first calculate A. How much is A? Modulus of A, root over of 1 square, 1 square, 1 square minus 1 square, that is root 3. Similarly, mod B is also root 3. So, and what is A dot B? A dot B, A dot B is equal to, what is cos theta? Cos theta is, let me rub all this. And another thing, remember, dot product, if when you do similar to sums, let me write this, similar to sum, A dot B is equal to multiplication of I into I, that is 1, plus multiplication of j components, that is 1 into minus 1, plus multiplication of k component. So this becomes 1 minus 1 minus 1, that is minus 1. So the very good thing about dot product is everything is very simple, as simple mathematics. A dot B is simply you multiply. You don't have to do I mean A plus B plus minus C, you understand? You don't have to do something like you do like this, right? A plus B minus C and A minus B plus C equal to A square minus AB. No. There are so many components, you know that, right? You do like this, AB minus B square plus BC minus AC plus BC minus C square. We don't have to do, no. Here it's, if it's a dot product, the I component simply gets multiplied. The I component gets multiplied by I component, Z by Z, and all are summed up. So similarly, the I coefficients multiplied, J coefficients multiplied, K coefficients multiplied. So A dot B is this. Okay. So A dot B we calculated as minus 1. Also we calculated dot modulus of A is equals to root 3 and modulus of B is equal to root 3. So now A dot B equals to modulus of A, modulus of B cos theta. So cos theta is equal to A dot B, which is minus 1, by A modulus of this becomes root 3 into root 3. So this is minus 1 by 3. Theta is equal to cos inverse 1 by 3. Refer to any tables and you will get the angle, or you can leave it as it is. Understood? Good. Let's move on to another problem. It says what is the second problem says? If A equals to, sometimes things need to be checked before they are done. So it's getting okay. A equals to 5i. See, I am doing all this from your books, but things are, and B equals to I plus 3j minus 5k. Show that A is perpendicular to B. You know, A is always perpendicular to B when they are at at 90 degree. So I need to prove, do I need to calculate angles? Yes, definitely. So first of all, no, so that the vectors A plus B and A minus B, sorry, A plus B and A minus B are perpendicular to each other. So first I calculate A plus B. Very simple. I add up 6i minus 2j minus 8k. A minus B, simple mathematics, 5 minus 1, 4i minus plus 2j, and this becomes, no, this is, sorry, A minus B, right? So minus 1 minus 3 minus 4 j cap minus 3 minus 2 plus 2 k cap. Now they are perpendicular to each other, so let's plot A dot. So perpendicular means this you have to show as 0. So A dot B, do it simply. A dot B, 6 4s are 6 into 4 plus minus 2 into minus 4 plus minus 8 into 2. This is 24. No, something I have done wrong. 6i, this should be plus. Yes. 24, this is minus 8 minus 16, so this is equal to 0. So that is why, therefore A is A. This is not A, sorry, A I am doing A minus, this I have written A dot B, no, this is A plus B dot A minus B. So therefore A plus B perpendicular to A minus B. So I hope I was clear today. We'll solve a couple of problems in the next class, and then we'll cover projection of a line. Projection of a line is very simple. Projection of a line on another, projection of one vector on another vector. This a couple of problems there, and cross product in the next class. Hopefully you liked my class, enjoyed my class, and do subscribe my channel if you liked and enjoyed the video. Thank you so much for watching. Thanks. Bye.